Greetings to all. This is Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the thrashing in operating systems. Thrashing. High paging activity is called the thrashing. If a process does not have enough pages, the page fault rate is very high. This leads to that low CPU utilization, and then operating system thinks that it needs to increases the degree of multi-programming, and another one is another process is added to the systems. Next one, when the CPU utilization is low, the OS increases the degree of multi-programming. Next one, if a global replacement is used, then the processes enter the main memory, then it tend to the steal frames belonging to the other processes. Eventually, all the processes will not have the enough frames, and hence the page fault rate becomes very high. Thus, swapping in and the swapping out of the pages only take place. This is the cause of thrashing. Here we have the diagrammatic representation, that is this side. We have that CPU utilizations. Here we have the degree of multi-programming. When that it comes under the low, the thrashing happens. Next one, to limit the thrashing, we can use the local replacement algorithm. To prevent the thrashing, there are two methods, namely working set strategy, page fault frequencies. First one is working set strategy. It is based on the assumption of the model of locality. The locality is defined as the set of pages actively used together. Next one, working set is the set of pages in the most recent page references is the working set window. Here we have the three condition. If it is too small, it will not encompasses the entire locality. Next one, if it is too large, it will encompasses the several localities. If it is equal, it will encompasses the entire program. Next one, D is equal to WSSI. Here we have that WSSI, that is the working set size for the process I. D is the total demand of the frames. If that is D, the total demand frame is less than M, then the thrashing will occur. Next one is page fault frequency scheme. That is, if the actual rate is too low, the process loses the frame. Next condition is, if the actual rate is too high, the process gains the frame. Some of the other issues we have, that is four issues we define here, that is pre-paging, page size, TLP reach, and the input output interlook. Next one, other issues, that is four issues we defined uh, already. That first one is pre-paging. To reduces the large number of page fault that occurs at the process startup. Pre-page all are the sum of the pages the process will need before they referenced. Next one is, but if the pre-paged pages are unused, input, output, and memory are wasted. Next one is page size. Page size, that is selection must take into the consideration, that is fragmentation, table size, input output overhead, and the locality. We have that four consideration in the page size. Next one is TLP reach. The TLP reach, that is amount of memory accessible from the TLP. TLP reach is equal to TLP size into the page size. Actually, from this one only we have calculated the TLP reach. Ideally, the working set of the each process is stored in the TLP. Otherwise, there is a high degree of the page fault. Increases the page size. This may leads to the increases in fragmentation, as not an all application require the large page size. Next one, provide the multiple page sizes. This allows the application that require the large page size the opportunities to use the without an increasing in fragmentation. Last one, input output interlock. The pages must sometimes be locked into the memory. Let us consider the input output pages that are used for copying a file from the device must be locked from being selected for eviction by the page replacement algorithm. Thank you.